Hello, I'm Carter. In this video, we're going to explore whether we can get a computer to recognize if a question is sincere or not. But first off, what is a good question? Is a good question one where you get to show off your knowledge? Is it one that is so jammed full of technical terms that listeners need Wikipedia to even understand what is being asked? I think that a good question is one where you're honest about what you know and don't know and actively seek to bridge this gap in your understanding. What makes a bad question? When I was in elementary school, one of my teachers told us, in this classroom, there's no such thing as a bad question. Someone in my class raised her hand and said, well, what about this one? Can I get a chili cheese dog with extra fries? I thought this was both hilarious and demonstrated a valid point. To me, that seemed like a bad question. My teacher responded with, that is not a bad question, but a silly question. The question, can I get a chili cheese dog with extra fries, in this context is insincere. The point of the question is not to learn about the world, but to make a joke. An insincere question is one where the speaker is trying to communicate something other than what is directly being asked. Let's look at some examples. All right, as I'm sure you all know, the exam is next Monday. Does anybody have any questions? Yeah, Alonzo? Will the fact that the lambda calculus and the Turing machine are both equally powerful models of computation be on the test? That will not be on the exam. This is programming 1. I didn't think so. I just wanted to demonstrate that I knew that. Noted. Thank you. Does anybody else have any questions? Yeah? Yeah, is it cool if I park my 2019 Audi R8 in the student lot before the test? I'm not sure. I would call student parking and see what they have to say. Yeah, I talked to student parking. They said it'd be chill. Then you should be fine. Dope. So how are we going to get a computer to understand whether a question is sincere or not? We'll do this by creating a late submission in a Kaggle competition, specifically Quora's Insincere Question competition. Kaggle is a collaborative data science platform. Organizations post data science challenges and Kagglers compete to see who can make the most progress in solving them. Quora is an open platform where users can ask and answer questions. Their goal is to grow the world's knowledge through questions. They are hosting this competition to explore whether they can automatically remove insincere questions from the platform. Our goal will be to build a sincere question classifier. It'll take a question and tell us whether or not it is sincere. The metric we'll use to measure our model's performance on questions that weren't seen during training is the F1 score. This is a combination of two other metrics, precision and recall. Let's explore what this means. Let's pretend that this is all the questions that we'll be evaluating our model's performance on. The X's represent insincere questions and the O's represent sincere questions. This middle circle are questions that our model predicted as insincere. Precision is a measure of the fraction of questions that our model correctly labeled as insincere over the total questions our model predicted as insincere. High precision will mean that most of the questions that our model predicts as insincere are in fact insincere. Recall is a measure of the fraction of the questions our model truly labels as insincere over the number of truly insincere questions. A high recall will mean that most of the truly insincere questions are correctly labeled as such by our model. The F1 score is the harmonic mean between precision and recall. We'll extract information about our question and learn to model whether or not the question is insincere as a function of this information. We'll model this relationship using a neural network. A set of weights and nonlinear activation functions will be applied to this information, and output will be a prediction for whether or not this question is insincere. We'll take this prediction and measure the distance between it and the true label using a cost function. We'll minimize this cost function using gradient descent. 3 Blue 1 Brown has a great set of videos that explore how a neural net works. I would definitely recommend these. So how can we extract useful information for our model? We can analyze the words that make up sincere versus insincere questions and see if we can notice any patterns between the two. What if a question in the testing set contains words that weren't present in the training set? Is there a way to capture a word's meaning without having to look at the actual character representation of the word? The idea here is that words like cat and feline have very different character representations, but very similar meanings. Ideally, our classifier should be robust enough to be able to ignore the different character representations and just pay attention to the meanings. We can make use of word vectors to accomplish this. The idea is to map words into vectors that represent their meanings. The vectors for words that have similar meanings should be very close to each other. Vectors for words that have very different meanings should be very far apart from each other. Luckily for us, many organizations have already created these mappings between words to vectors. Let's take an example question and see how we can extract information from it using its word vectors. We can split the question into its words and map each of these words into its vectors, represented as arrays. Then we can take the average of these vectors to get a vector representing the meaning of the question. This approach has been shown to work all right in practice. We can look at a few thousand sincere questions, compute their meaning vectors using the process just described, and take the average of these. Our hope is that this gives us some proxy for the meaning behind a sincere question. We can repeat this for 1,000 or so insincere questions also. Let's assume that we've used this process to compute a sincere meaning vector and an insincere meaning vector. Now we can take a question, compute its meaning vector, and compare this vector to each of these. The distance between this vector and each of these vectors can be features for our model. We can also look at common words that are present in insincere questions but not in sincere questions and compute each of these meaning vectors. We can then take our candidate question and compute the distance between its meaning vector and each of these vectors. This will give us a whole bunch of features for our model. Let's try to code this up. We can head on over to Kaggle.com and go to the Quora Insincere Question Classification Competition. I've already made my kernel for this, but if you want to make one, you can hit New Kernel. As you can see, I've already coded up my solution to this. I'll try and explain what I've done. Right here is where we'll load our embeddings. We'll be using the glove embeddings. Basically, we'll load this from a file and get a dictionary mapping words to their vectors representing their meanings. This function will be used to take a question, extract its words, and map each of these words into the vector that represents its meaning. Then these vectors will be stacked on each other, creating a matrix. This function will take that matrix and perform the mean along the words. So we get the average vector for this matrix. Here's an example of the matrix being formed. And here's an example of the vector being formed. We'll read in our data and split the training data into the sincere and insincere questions. Then we'll sample 10,000 sincere questions, compute the vector as described in the video, and take the mean of all these. We'll do the same thing for the insincere questions. Now we'll find the most common words found in the insincere questions, subtract the words that are found in the sincere questions from these counts, and get the most common insincere words that are not present in the sincere questions. Now we'll whittle this down to the words that are represented in the embeddings. Now we'll begin our feature extracting function. We'll calculate our questions vector using the process described, and we'll calculate the distance between this vector and each of the common insincere question vectors. We'll also calculate the distance between this vector and the average sincere question and average insincere question vector. We'll return a list with all these features in it. This function will take our data frame and apply the feature extraction function to each of the questions. These two functions create Python generators. I would look this up if you're unfamiliar. We can't fit all of our data into RAM at once, so we'll have to apply it step by step. Generators will let us do this. We use the Keras library to build our neural net. It provides a really easy way to do this. We'll train our neural net using the generator we created. After the neural net is done training, we'll use it to predict on the testing set. We'll write the results to a CSV. So how did we do? Not well. If we look here, it looks like our model has predicted that every single question is insincere. This is unideal. What else can we do here? If we could look at the order in which the words in the question appear, we might be able to detect patterns of meaning expressed over time. Let's try a different type of neural network, an LSTM. LSTM stands for long short-term memory and is a type of recurrent neural network. Recurrent neural networks are able to process time series data. Our goal will be to model the relationship between meaning expressed over time and whether or not the question is sincere. Brandon Rohrer has a great video on recurrent neural networks that I will link to in the description. Let's look at some examples where analyzing meaning over time might clue us in to whether the question is sincere. As we can see with these two examples, they both share similar words but express very different meanings. What we hope is that the model picks up that phrases like all members of a political group are bad indicate that this is probably not a sincere question. Let's look at the code for the LSTM. Much of the code is the same. We still load in our embeddings. We still have our extract words and question embed functions. Now, all we're going to do is return the result of calling question embed on the question, which is just a matrix with each of the words in the question mapped to their vectors. This will be all that we'll be feeding our model. Our new model is quick to define, just like the last one. And just like the last one, we write our results to a file. How did we do on this one? We did better on this run. These F1 scores are decent for this competition. In this video, we trained a computer to detect whether or not a question is sincere or not. The approach we used here really just scratches the surface on techniques that can be used to solve this problem. I would highly recommend checking out some of the other kernels in this competition. I definitely made use of them when coming up with my solution. Thanks for watching.